Microservices is a word that when I started teaching this class maybe 5-ish years ago, basically didn't exist. Service-oriented architecture was a word that existed, but at the time, there was a lot of skepticism about whether it meant anything or whether it was just like some marketing buzzword, like, I don't know, cloud computing. But those things have changed, and now they mean something. So here's sort of the history of the World Wide Web in one slide. By the way, if you're wondering how I can squeeze the history of anything into one slide, it's because the book and the other videos on edX have a lot more detail. So we're trying to sort of cover the bases up here. So dynamic content generation. Life on the web used to be really simple, because when the web first started, the only thing you could really name with a URL or a URI was usually a static file on a disk somewhere. So you had a document that had HTML, maybe the document had some images embedded in it, but pretty much there were files sitting on some computer, and HTTP was just being used to transmit a request to basically get a copy of those files. That's, in fact, how the web started. It was originally a way for scientists to be able to easily publish papers that had graphics and things in them, and to be able to easily retrieve each other's work. So sort of from these humble beginnings is where the web began. But once e-commerce was sort of invented, that made life a lot more interesting, because an e-commerce site doesn't really serve pre-existing pages off of a disk. It basically runs a program to generate the page, right? So when you visit Amazon.com's front page, there's actually an enormous number of little pieces of code that each of which is producing some little part of the Amazon homepage, right? The stuff recommended for you, the things that are on sale, the drop-down showing how you can get to your orders and your account and all that other stuff. So this is pretty important, because now a URL is not the name of an existing static thing, like a document. Now a URL is a way to invoke a remote program that will generate on the fly something that the browser can show you, right? So that's kind of fundamental shift number one in the web, is going from URLs equals a static file on a disk to URL is a way to name a program that will run and will generate on demand what that page is going to look like just for you. The second major innovation came in the form of AJAX, which we're going to talk about in more detail later in the course, but it stands for asynchronous JavaScript and XML. If those words mean nothing to you, don't worry about it, because at this point they probably shouldn't. But here is the main change that AJAX brought with it. And I actually remember the first time that Google Maps appeared, and that you could drag the map around and it would sort of redisplay. You could zoom in and out, and it would never reload the whole page to do that. And that was a big deal, because for the first time, previously every time the client, the browser, would do an HTTP request, the server would send back a whole bunch of new stuff to be displayed, so the web browser would redraw the whole window. Now, AJAX added this new capability, which is even after the page has been loaded and displayed, JavaScript code running in the browser can still make other HTTP requests in the background back to the same server. And now, instead of the server delivering new stuff to be displayed, the server is delivering data. And the JavaScript code receives that data and can use it to make changes to the stuff that is already on the screen. So some people started calling this single-page apps, because once you had loaded the first page in your web browser, you never really did a full reload. You were just having interactions that would change bits of the content on the page. So this was kind of a huge deal, because now the relationship is changing again. Before, we were saying, OK, we're not getting static files anymore, but at least it is still the case that a URI names a thing that is going to be returned and displayed. Not anymore. Now, a URI can name something that will result in data coming back. And what to do with that data, how to use the data to change the display, is now something that is up to the client, so in particular, JavaScript code that's running in the browser. So now, HTTP request and reply is more like calling a function in a library, right? You're calling a function, and what do functions do? Well, they may cause some side effect, and they probably return a value. They return some data. So now the web is really more like a bunch of sites that you can think of as independent functions or services. And you could imagine putting those things together and sort of building a program just the same way that when you're writing, let's say, Python code, you can pull in different Python libraries, call functions in those libraries, and sort of make use of them as existing black boxes. So that was the beginning of what was really called a service-oriented architecture, because now we're not talking about each site as being necessarily the one important thing. It's what does that site do, and how could you combine what that site does with what other sites do. And interestingly, Amazon was one of the earliest adopters, because I've sort of simplified dramatically what Amazon might look like, but the bottom line is that from the point of view of the user, Amazon is a single site. It was a bookstore back then. They actually weren't selling a lot of other stuff. And sort of inside the boundary of that bookstore, there was a thing that let you buy stuff. There was a thing that managed your user profile so it could make recommendations. There was a thing where if you reviewed a product, it would store that information. And the databases that different kind of information was stored in were all sort of accessible to different services. So when you were going to write a review, that would be linked to the reviews, but it would also be linked to you as a user so that it could tell how many reviews you had done. If you were buying some stuff, information from the user's database that took advantage of reviews could make recommendations for you. So even though there were distinct pieces of functionality inside Amazon, they all sort of had access to each other's data. And Jeff Bezos sent around this memo, I think around in 2007 or earlier. The exact date's in the book, but I've forgotten by now. But basically, what he said is, we need to become a service-oriented architecture, by which I mean any service inside Amazon, like the one that does buying, the one that manages profiles, whatever it is, it has to manage all of its own data. That means that, for example, if the buying service now needs information about the user, like your billing address, it can't just sort of reach into the user's database like it used to. It has to ask the user profile service in some predefined way to give that information back. And if the user profile service doesn't have an advertised way to do that, then the people who run this service have to modify it so that it meets that need. So this is a really, really big step, right? And Bezos said, I don't care how you do this, I don't care which protocols you use, but anybody who doesn't do this will be fired. So make Amazon work this way now. And his idea was that every one of these little pieces of services might eventually be something that everybody else, like random users like you and I in the outside world, might make use of. So we could just look at the Amazon product catalog. So if you had a version of Amazon that worked this way, you can imagine that you could now build a new service outside of Amazon that got information from people's user profiles and from reviews and sort of made some recommendations about books you might like. And you could even imagine connecting that service to some social network so your friends can figure out which books you might like. Because thanks to things like Facebook, your friends do not already know enough about you. So this was a pretty major step. And the key distinction between the left side and the right side comes back to this. No service can directly name or access another service's data. It has to make a programmatic request to that service saying, hey, the data I'd like is whatever, please give it to me. It can't just sort of reach around the service into the database and grab the data sort of in its raw form and do whatever it wants. Service-oriented architectures are great for reuse. We know reuse is like one of the holy grails of computer science because you're reusing the whole service, right? The service just sits there answering client requests all the time. It's not like you even have to treat it like a library. And because it doesn't matter what the language is used to implement the service, you can use the best tool for the job. If the best tool for that particular service happens to be JavaScript, you can use that. If it happens to be PHP or Ruby or something else, as long as the only thing the client sees is what are the routes and URIs that it is allowed to ask for, and what can it expect in return. Arguably, it's easier to test, because if each service is only doing one thing, if you're only testing the recommendations database, that's easier than testing sort of all of Amazon. In other words, the less functionality you have and the more tightly coherent it is, the easier it is to sort of test that one piece in isolation. And you could argue that it's more agile friendly because as we say in the book and in some of the supplementary videos, one of the big features of Agile is that it tends to work really well on smaller teams with smaller projects. If you're doing a service that doesn't do a lot of different things, that's more likely to be a good fit for a smaller project on a smaller team. So you could argue that a microservice, which does one thing very, very well, right? Like Stripe is an example of a microservice. All they do is credit card payments. You can connect it to any other website, but Stripe doesn't do anything for you except that one thing. They manage payments. Services like that sort of do one thing very, very well tend to be a good fit for small agile teams. And for the same reason, the same team that builds the service is often the team that is operating it. Werner Vogels, who's the CTO of Amazon Web Services, says, you build it, you run it. So in some ways, you could say, well, that's actually that's not bad, because part of the benefit of Agile is if you get feedback from your customers on what they want, you want to be able to quickly act on that feedback. If the same people who are the developers of the service are also the ones who control deployment, then that feedback cycle is shortened, right? The same people who can make the changes can get the changes deployed quickly. And in fact, as we're going to do in this class, deployment comes down to like you could be deploying several times a day. Right? Amazon and Facebook both push production code many times per week. Now, there's a dark side to all that, of course. The services are reusable, but now you have to worry about state being split across different services. So in my simple example of building an external bookstore recommendations kind of service, the reviews are over here, the catalog is over here, and I'm going to have this new information that I keep that depends on both of those. So I now have some information that is dependent in some way on information that is at those other sites and could change at any time. That's not a problem if I control the whole site, right? In the original version of Amazon, if the information about users changes, I can immediately reflect those changes in the information about the review service or something. But if those different pieces of information are now stored in different services, now it becomes my problem to say, okay, how do I check if one of those goes out of date or has changed out from under me? Yes, you can use the best tool for the job because the only thing that matters is the interface that the HTTP client sees. However, that means that all of that data that the client has to be able to see, you have to have a way of being able to transmit it to the client. And we're going to see a couple of different data formats, especially JSON, that are used for using this. But the bottom line is everything going in and out of that service now has to be translated in advance to a format that can be shipped over HTTP. So what would be an example of not doing that? Well, if you've got data stored in like a big database, like an SQL database of some kind, and you can reach directly into the database to just get the data that you need, you don't care how the database is storing the data internally. You just care about doing the query you want. But if you're now going to have to pull that data across an HTTP connection, the data has to at some point be in a format that can be transmitted that way. So you have to serialize it. You have to agree on what the data is going to look like while it's in transit between the client and the server. Something that is invisible if the services are actually commingled inside one boundary. I said that it was easier to test, but it's also harder to test. Because now when I test my bookstore service or my bookstore recommendation service, it actually depends on two other services. So a way that my service can fail is if one of the services that it depends on fails. So I have to have something in my test plan to make sure that my testing can account for that. And at operations time, right, at runtime, my service could be down. Even though my part of the service works, the services that it depends on might be having problems. And now I have to handle that case. Whereas again, if I control the entire service, then either the whole service is up or the whole service is down. But I wouldn't have a situation where like part of the service is up. Now I have to deal with that situation separately. I said it's more agile friendly because a small team can build and operate a small service. That's true, but performance can be quite tricky because now you are like the payment service for everybody in the universe. So certain aspects about performance become much more severe because you are allowing other services to use you as a building block, right? If you build your own credit card processing inside of your retail site, you are the only customer of that piece of the service. But if you're just building credit card processing like what Stripe has done, everybody in the universe is going to use you as their payment processor. And boy, are they going to be mad if you go down, right? So, and this is a question someone raised last week when we talked about cloud computing and Amazon Web Services. And someone said, well, if AWS is hosting all of this infrastructure for all these companies, and if AWS has a failure, that's a really, really sad day for all the companies that are renting capacity on AWS. So this is the same idea. If you have a service that is really highly used, right? Like if the login by Facebook portion of Facebook has a problem, and all of a sudden nobody can use login by Facebook to get to all the zillions of websites that they have indicated they're logging in by Facebook, that's a very sad day at Facebook. And finally, what a great thing that the same team that builds it can also operate it and quickly make changes. That's good, but it means that those people are now not just developers, they are developer operators or DevOps. So you may never have been a system administrator in your life, but in this role, you're going to have to learn a little bit about system administration. You're going to become somebody who's responsible for both an operational thing as well as the development of the code. And although it requires building out those skills, in the long run, it is actually, I think, a net win that you build and you run. So this is the world that we now live in, right? It is a done deal that this is what the web is like. The web largely consists of services that you can put together. And the nice thing is that you can just concentrate on building the part of your app that is different and unique. You don't have to build payment processing. You don't have to build redemption of coupons. You don't have to build login, because other sites have built those things and you can just use them. Just like when you're writing a program and you get to use libraries that solve some problems like that off the shelf. Okay? So that's the world we live in, and we're going to now transition to talking about what that world looks like in the context of web services specifically and REST.